G'day guys, I'm just going to go through differentiations of polynomials with you today. So you could hit up a record of learning, call it differentiation of polynomials. So from Greek, poly means many, and nomial comes from nomen, which was name. So basically it's the name that we're giving to things that have many. And what the many is many variables and coefficients. So a polynomial is an expression containing variables and coefficients that involves only addition, subtraction, multiplication, and division. So a couple of examples here. The quadratic, x squared minus 4x plus 7. It's just got multiplication, subtraction, and addition of variables and coefficients. So variable x, coefficient of 4, and a coefficient of 7, or a constant of 7. Another example is x cubed plus 2 xyz squared minus yz plus 1. It's also a polynomial. This is straight off the Wikipedia page, by the way, because it's got 3 different variables. It's got a coefficient of 2 and negative 1 and 1 and a constant of 1. So it's also a polynomial. So what I wanted us to get into is deriving polynomials. So the first things we learned to differentiate. So from our last video, we learned that we multiply by the power and then reduce the power by 1. So we start with our notation, f prime of x, and this is 7x to the 4 plus 3x. So we times by the 4, we reduce the power, and we can then do the same thing for the next variable. So the reason this goes just to 3 is because imagine there's a 1 on there. Well, times by the 1, you get 3, and now reduce the power by 1, so you'd have x to the 0. And we know that anything to the 0 is 1, don't we? So that is as easy as it gets, really, for differentiating polynomials. This one's a little challenging. So this one is 2x cubed over 3. Well, it's the same as having 2 over 3 times x cubed. So f prime of x is going to be times by the 3. Well, those 3's are going to cancel. We're going to actually be left with 2x squared by the time we reduce that power. So 2/3 times 3 is just 2, and then x squared, and so that is our derivative function. This one here, so we can't derive this straight away, and I'm going to show you why. You guys haven't been taught how to derive when a variable is a denominator like that. So we need to rewrite this in a way that's a bit more familiar. And so this comes back to that surge stuff we did. So that's the same as 2x to the minus 4. Now we can derive f prime of x is 8x minus 1. Take away, because it's going to be negative 4 times 2. And now reduce the power. Now, don't go to 3, go to negative 5, because that's going down by 1. And then you can rewrite this as 8x minus 1 minus 8 over x to the 5. So we're using a little bit of our algebra skills, and there we have our derivative. 8x minus 1 minus 8 over x to the 5. So this one's a little tricky because you've got, it's kind of like a mixed number or something. You've got this fraction in here, which could throw you, but just remember that's 2 over 3 times x cubed. And this one's a little challenging as well because you've got 2 over x to the 4. Okay, so we have to write that just in power form. So we have all the powers on the same line, and then we can do our derivative, and then we can always put it back afterwards. So I think I've got a couple for you to try here. So f of x is x squared minus x plus square root of x minus 1 over x. That's one problem that you might want to just try. And here's the other one. F of x is 2x squared minus 4x plus 3 all over 2x. So let's go ahead with this one. I would need to write this in power form first. So f of x is x squared minus x plus x to the, and remember that square root is power of a half. and then we take away x to the -1. That's just x to -1. So now we can do the derivative. F prime of x is now 2x minus 1, just because it's a power of 1, so it's just going to have a constant in front. And now this one's a wee bit interesting. Times by the power, reduced power by 1. So a half take away 1, it's -1/2, isn't it? And now we have -1 times -1, so plus x reduced to power -2. We've done the derivative, but I want to answer how we did before. So f prime of x is 2x minus 1 plus, now this one's quite interesting. We can put the x to -1/2 on the bottom with the 2. So we can have 1 over 2 square root x. Because if that goes at the bottom, it has a positive power. And you know that x to the half is square root. And it's pretty similar here, plus 1 over x squared. So that is your derivative. So I might just make a wee note of that. A half x minus a half, well that's a half times 1 over x a positive half. So that's 1 over 2x to the half, which is 1 over 2 root x. So that was just my working I did in my head there. This one's a little interesting as well. You can't just go straight ahead and derive this. You need to cancel out the x's. So f of x is going to be, what's 2x squared over 2x? Oh, it's just x, isn't it? -4x over 2x is -2, right? Because x's would cancel. And then we have 3 over 2x. So I've just divided into each of those. And it wouldn't work up the other way, would it? So, derive this, it's 1. The derivative of a constant is 0. And here we have, actually, I need to write this with the power on top. That's 3 over 2 x to -1. So f prime of x is 1, take away 0, plus, or minus, sorry, -1 times this, reduce the power. So this is going to be 1, take away 3 over 2x squared. And there you have the derivative. So that one wasn't that very smooth, was it? So first step was I divided this one out because I needed it to just be a polynomial in one line really. Later on in this unit you'll learn how to deal with these in a bit more of an efficient manner using something called the quotient rule. But today we're just using algebra, so divide that out. Write it out in terms of just powers. Not like this, in terms of just straight powers. Take the derivative, so 1, 0, and our -3 over 2, x to -2, and then simplify, so 1 minus, that's 3 over 2x squared, because that can go on the bottom with a positive power. Nice.